Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 305. The problem name is check if there is a valid partition for the array. So we are given a zero index integer array nums and we have to partition the array into one or more contiguous subarrays. Now we call a partition of the array valid if each of the obtained subarrays satisfies one of the following conditions. So a subarray consists of exactly two equal elements. For example, subarray 2 comma 2, that is good. A subarray can have exactly three equal elements, that is 4 4 4, that is also a good subarray. Also, a subarray consists of exactly three consecutive increasing elements, that is the difference between adjacent elements is 1. For example, the subarray 3 4 5 is good, but the subarray 1 3 5 is not good. Okay, return true if the array has at least one valid partition, otherwise return false. Let me just pull the code and then we can go to the explanation, right? So it is saying that I have an array. Suppose I'll just take the first example, 4 4 4 5 and 6. So what I can do, I need to tell whether this is a valid array or not. Valid, this array can have a valid partition or not. Now there can be three valid cases. The first one is having two equal elements, right? Having three equal elements, and the third condition is three elements, three consecutive elements, right? These are the three conditions. Consecutive, right? So in this one, if we see, then we can make a partition of 4 4 and then we can make a partition of 4 5 6. So 4 comma 4, this condition is satisfied. 4 5 6, this condition is satisfied, and we have partitioned the complete array, so we return true here, right? Let's come to the second case. It's 1 1 1 and 2. Now just see, is it possible to do it? Now if we make 1 1, then also we need three consecutive elements. We'll not be able to do. If we make 1 1 1 as one partition, then also 2 2 is alone. So that means this array cannot be partitioned into a valid array, right? So that's what we need to do. Now this is these are the three conditions that we need to satisfy. Now just think in terms of breaking this problem. Okay, suppose I am at position I, right? I am at position I. Now what happens, just see, if this element and I minus 1th element, if these two elements are equal, that means there is a possibility of forming a valid partition if I consider just these two elements, right? So if I have calculated whether the elements before I minus 1, these elements, or I would say this subarray, if I was able to form valid partitions for these elements from 0 to I minus 2, right? So if this was true, that I was able to form a valid partition, then I know I minus 1 and I are forming a valid partition by the first condition if these two elements are equal, right? What is the second condition? The second condition is if I am at the ith position, if ith element is equals to I minus 1th element and I minus 2th element, that means these three elements are equal. So just think, if I was able to form a partition, a valid partition from 0 to I minus 3, right? That means if this was true, then obviously these three are forming a valid partition. Good, we are good to go. The complete array is forming a valid partition till the ith position, right? What is the third condition? Three consecutive elements. So again, if we are at a ith position, right, so we check I minus 1 and I minus 2th position, right? So what we do, we check whether is the difference of this and this equals to 1 and the difference of I and I minus 1 equals to 1. That means checking whether these three are consecutive elements or not. So if I have calculated the result of I minus 3, 0 to I minus 3, which tells me that whether or not this subarray we were able to transform the subarray from 0 to I minus 3 into a valid partition. If we were able to do, so we are able to do it till the ith position, because these three are also forming a valid partition, right? So what is the common thing that we are seeing here? The common pattern that is coming here is we are saving the state of previous indices and then we are checking for the current indices. Here uh, two consecutive indices, here consecutive 3 and consecutive 3 for all these three conditions. Now if any of these three conditions satisfy, I know I have a valid partition. So right now, how will we store this result that we are talking about? So this is a typical dynamic programming problem. You store the results of 0 to I minus 3, and so this is valid for all I. You store the results for suppose I minus k, right? I minus k, and then you verify whether I minus k plus 1 dot 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 if this is valid or not. Here in this case, what we are doing, I need to store result for I minus 2, I minus 3 and so on, because obviously I at ith position I need to check the last two elements or the last three elements, right? So typical dynamic programming problem. Let's jump to the solution to get a better understanding. So here you can see I have taken on line number 4, I have taken a boolean array, a dp, which represents whether or not dp of I represents that whether subarray 0 to I is forming a valid partition or not, or basically that subarray can be basically transformed into a combination of valid partition or not, right? So that's it. Now what we do, dp of 0 is true, because if you have just if you don't have any elements, that will be true, right? Now we start reversing from I equals to 2, I less than an I plus plus. So what I do, just see here that I check for the first condition, nums of I minus 1 equals nums of I minus 2. If this is true and dp of I minus 2 is also true, then dp of I is true. What does this mean? That means I am at ith position, I'm checking the last two positions, current and the previous one. Here the indices, what I have done for simplicity, I have taken the indices from 1 to n. Originally it is 0 to n minus 1 only, right? That is why I'm doing I minus 1 and I minus 2. For dp array I have taken from 1 for simplicity, right? So when I'm at the ith position, I'm checking the ith and the I minus 1th position. If these two are equal and till I minus 2th position my array was forming a valid partition, we are good to go. So that is what we have done. dp of I minus 2 is true and nums of I minus 1 and nums of I minus 2 are equal. dp of I equals to 2. First condition, if satisfied, dp of I is true, right? Let's come to the second condition. The second condition is if nums of I equals nums of I minus 2 and nums of I minus 2 equals nums of I minus 3. Meaning if the last three elements are equal, and before that the subarray was forming a valid partition, then dp of I equals to true. Similarly, the third condition, if the last three elements are forming three consecutive elements, then we are good to go if dp of I minus 3 is also true, right? So these are the three conditions that we are checking. We have added an if condition, so if any one of them satisfies, we are good to go, because the question says that any one of can satisfy, right? So yeah, finally we return dp of n. So yeah, that's all about this problem. I hope you learned something new from this video. Please do support it by giving a thumbs up. Also do subscribe to the channel. In case you have any queries, do mention that into the comments. Also these type of problems can be solved by practicing more and more similar problems. Once you start practicing these problems, you'll be able to find that okay, this is a pattern that is being formed in the problem. So you know that okay, I am dependent on the previous states, so that means I need to save that state somewhere. So there you will see okay, it's a dynamic programming problem, and yeah, so more and more practice and we'll be good to go with that. Okay, so okay, take care, bye bye.